Hey guys, welcome to another Fischer Builds. This is my Ghostbusters Ecto Containment Unit. It doesn't have the full bay that opens up and you can put a trap in and everything, but I just wanted something aesthetically pleasing to cover up my ugly electrical panel inside my workshop. So I built this box and this backboard just to open up, connected with a piano hinge. All the wires are on the door, and then I can connect it and disconnect it if I ever needed to take it off for electrical maintenance. If I wanted to add more circuits or just have somebody working, this whole thing can come off in about 5 minutes. Now, sizing, this is oversized. This isn't 1-to-1 for the movie because I'm putting it on top of a 40-inch 200 amp panel. This is much bigger than what was in the movie. This backboard is 39.5 inches. The box is 29.5 inches, not including the scoop. The scoop at the bottom is a 17-inch square. The backboard is 3/4 inch plywood. I just got basically the cheapest stuff I could find that had a nice sanded surface. It's actually called Sandy board from Menards. One piece of that covered the entire back, and I used a half piece because the middle's cut out and it's pieced together, so it's actually not even a full piece if you were to do this exact project. If you were making a full-size replica with the bay and everything, you would want a continuous piece from top to bottom. You would need a full sheet. The sides of the box are made out of 1x material, so it's just 1x8s is what it was. I bought 2 8-foot boards and then cut them each, and then ripped them down. The front is a 1/2 inch plywood, and that was super smooth. I had to take wood filler occasionally and fill in little knots and whatnot and sand them smooth before painting and building everything. But you get a nice piece with few knots and you're actually well ahead. The trap bay is an additional piece of the 1/2 inch. It's just cut out and I rounded the corners. Same as up here, it's the same bevel. This is just an additional 1/2 piece stuck on, and then this is a piece of 1/4 inch that I had laying around. I just cut, and I cut through this piece so that this area is recessed, but it's actually just this surface. So it just gives it some depth with that ring around it. And then this handle doesn't do anything. It's just carved out of a chunk of wood. And then I put a Chicago screw in it just so I can turn out. Give it a little more. And then the hinge, obviously not functional. This is just 1-inch PVC pipe with, I believe, 3/4 or kind of 7/8 dowel going through it. And then the weld from the hinge to the door is just hot glue. And to get this to sit nice and to glue nice, I just took each of the pieces of PVC and held them down to my belt sander just to flatten one side of it. It takes just a couple seconds because PVC will sand very quickly. And then now it'll actually sit flat against the panel when I glue it down. Inside, I cut out squares, 3x3, just to give it some rigidity because a box with 4 sides with nothing inside, it doesn't have the best structure. So these hold it in place and keep it a little bit more true and square. Now, disclaimer, I'm not an electrician. This is strictly aesthetic. No actual wires were ever touched. Everything in this box runs off of a 12-volt battery that's mounted on the door, including the lights above. So nothing is actually plugged into the house. It's safe, but absolutely consult an electrician before doing anything like this. And a couple extra pieces. There's this little angled block. It's just a 4x4 that cut on a 45-degree angle. It's about 6 inches long. Cut it from 6 to 3, leaving 3 inches. It's really all it is a 6-inch board cut down. And then this little faceplate is 1/8 inch hardboard, the same hardboard I used to do that curve on the scoop. Just cut into a square with rounded corners and then tightened down with M5 bolts, which I used throughout the entire project. And then the blocks up here for the ribbon cable, this is a 4x4, this is a 2x4, just cut down, and I ran both of them, the 4 sides that are facing the ribbon cable, through the router with a round over bit, just to make it look a little more finished. Now, for the bulbs, I couldn't find a 12-volt red and 12-volt green bulb. the trick to this system is everything runs off of 12 volt. You can't run a 120 volt bulb on a 12 volt system. It just won't work. So I found 12 volt LED bulbs on Amazon. I'll put a link in the description. Scuffed them with like 000 steel wool. You don't have to do much. You just rub it all over the place just to give it a little bit of micro scratching, giving paint something to grab onto, a little bit of tooth. And then I ran it through with green and red transparent airbrush paint. Put it through the airbrush. I did 4 light coats, and in between each coat I hit it with a heat gun, very gently, and you can actually see it dry. It'll go matte from wet. So you can tell when it's drying, and it takes, 20 minutes to paint 2 bulbs, and now I have green and red bulbs. So truthfully, this project took a lot of different tools, and I have a very, odd skill set where I am mechanically inclined. I'm good with wood. I can also do electronics. I can weld, but this can be done with the basic set of tools. A circular saw to rip down wood. A table saw would be even better. A jigsaw to make roundovers. I actually used a router table with a template bit to do this, but a jigsaw with a curve, you can cut it on your own and sand it to where you want it to be. Drills. You're going to need some pretty big drill bits to cut big holes for buttons. 16 millimeter bit, you're talking more than a ½ inch. It's just past a ½ inch size. And then for a big hog like this, you could drill and use a jigsaw or big honkin' Forstner bits to cut big holes like this. Threaded taps for these screws. These are all M5 screws. I have a threaded tap, and I'll link all this stuff below where you guys can get these tools if you were interested in them. The only permanent fixture out of this entire thing are the lights. The lights are attached to my foundation wall, each with 2 Tapcon screws. Tapcon screws are designed to go into cement. You pre-drill with a masonry bit, vacuum out the hole, get all the dust out of there, because if you hit dust and the screw isn't all the way in, it'll snap off. So drill, vacuum it out, and then drive it home. I suggest using just a standard impact driver. Don't stop, just go straight in. Otherwise, if you stop and start, it's liable to snap off as well. I had 2 snap off on me in the masonry, so I had to shift the whole thing one way or the other. Can't really tell though, because I had mistakes. Well, that's the fun of making. And because I'm installing this box around an existing structure, I had to notch out going around for all of the existing electrical so that nothing actually touches. Everything I can stick my finger in and it'll never touch on anything. 2 cuts out on the top, 2 on the side, and 1 on the bottom. There's a surge protector at the bottom that you'll see in the assembly. So think ahead. You'll have to take some measurements in order to fit the box on, but once you do, it slides on and off rather easy, which you'll see. And now, as far as the mechanics go, the inner workings of this is all run off a 12 volt talent cell. Just 1 battery. An alternative to this, if you don't want to buy, this is a $30 battery, you can also buy 12 volt battery packs. They're basically double A's stacked together. 8 double A's equals 12 volts. You may not have the highest capacity, it may not run as long or as bright, but I do have them, and I was running them during my initial testing. 12 volts is 12 volts. It will work. If you were traveling, having multiple packs, you could have one of these and multiple of those 8 AA packs ready to go, and you can swap them out. Everything can get connected to these 12 volt plugs, and you just swap them out with the quick connects. Make your holster bay as big as you need to slide in the 8 pack, and you'll be fine. Also, with this, there's a charging port. That charging port is for a 12 volt wall outlet. So if you were at a con or you were at some kind of Halloween or expo or something, and you didn't want to be running on a battery all day and you wanted the overheads to stay on, you could plug in to the 12 volt and go into the wall with an extension cord. Just think ahead, maybe pop a hole in the side or out the back and give yourself an extension cord to reach an outlet wherever it may be. But you can absolutely plug this in if you wanted to and let it run all day. Now, the handle that operates the lights, that was the trickiest bit. How do you get the mechanics to work and switch the lights without using an Arduino? Nothing on here uses any control boards. It's all just switches. This is connected to a dual pole, dual throw knife switch. You can get them on Amazon, they're not that sophisticated. It's basically 3 terminals on each side, the neutral's in the middle, and then contacts above and below. Right now when it's up, it's contacting all the wires to the red, 2 wires to the red overhead light. When I pull down, it contacts the other side, which are the green. That's it. Because it lost contact with the red, it turns off the red at midpoint, about there. Pull down, the green light turns on. It's that simple. I'll put up a wiring diagram. Actually, if you guys want to see the full wiring, comment below and let me know. Say we want to see the wiring, and I'll do just a separate video and I'll post that in a week or 2 if it gets a good response. So to start, you just need to make a backplate. You take your measurements. Mine is actually larger than from the movie because I'm putting it over a 40-inch electrical panel. So take the measurements and you're just going to have the backplate going around 3 sides, and then there's a scoop that goes down the bottom. So to work around an existing electrical panel without disturbing any of these wires, and for safety reasons, I cut it into pieces, and as they piece together, it'll build itself all the way around. Now as you do this, you want to think about your seam lines. Because I have to have a seam, I use the existing pipes, the conduit, as camouflage for the seam. The electrical panel is actually held to the wall with the 3/4 inch plywood, so I'm pocket holing into that plywood. So it's just going to be a continuous piece of plywood behind the electrical panel anyway. So in this middle piece, I actually didn't pocket hole it. It kind of just sandwiches in between the top and the bottom halves. So once I put this in and pocket hole the top, it holds it in place. As well as with this pipe. And again, hiding seams. And this is the bottom plate that the scoop will come down on. So I did cut out all these notches for the piping and the surge protector underneath and everything, so it'll sit and rest right where it needs to. And just like before, pocket hole to the back plate, and now it's attached to the wall. I pre-wired the lights. All that's happening is 2 wires from each light is coming down this wire loom, and they each get hooked up to a quick connect. So if I ever need to take this panel off, I can. Now there's 2 conduits on the side, strictly aesthetic. They don't attach to anything. The elbow just threads in, and the backside just slides in. And because this is on a tight angle, it'll hold itself in position. And the scoop is just 2 pieces of 3/4 inch plywood. The whole box is made out of 6-inch strips, so I can cut this to 6 inches, just cut a regular piece, and then bow a piece from 0 to 6 inches, and that gives you your angle. And then I just put hardboard, 1/8 inch hardboard on the front, and these are furniture rivets. And you just hammer them in, they stick in anything. And this is just gonna be with pocket holes, just like everything else. And up on this top corner, there's a little ribbon cable. I 3D printed these little brackets. They're just short tees, and then each one has a 5mm M5 socket head screw in it, and I just bolt those both in. For a little DC microamp meter, I manually set it to be, 3/4 of the way up to show some power consumption. Just a little added touch. It's a flat panel. All I'm gonna do is put a couple dots of super glue just to hold it in place. But these bolts kind of grab. I've made this holes a little bit small. So a couple dots, and then I'm just gonna stick it in place. For the top knob, it was kind of hard to find, so I just carved one out of a piece of wood. Just made a triangle and then used a bandsaw to put some knurling around the sides. Drilled a big hole in the bottom of it, and then glued in one of those M5 socket head bolts. Threaded in a hole. And as you get it close, I like to leave a little more than 1/8 behind it. So if anyone turned the knob, it gives it a little bit of action. It just kind of adds a little bit of some interaction with it. So the middle bolt is my secret power switch. That's a real knob with a threaded set screw, and that'll actually hold it onto the knob, so when I crank this, it doesn't slide off or spin. This one's also fake, but it is a potentiometer. Same thing, just a set screw, but it doesn't actually do anything. So now for the buttons. These are rectangular buttons, 16mm shafts. You can get them on Amazon, I'll have links below in the description. And they are latching buttons. So you want them to be able to catch. That's part of the mechanics of this. This contraption doesn't use any Arduinos or control boards. It's all just wiring and switches in a certain sequence, and everything works together. So I'm gonna thread a nut on the back, but I don't want these to spin at all. So I'm gonna put a touch of super glue on the back so it catches. Yeah, I did. So I got the buttons on the door all wired up, and all I have to do is connect the upper lights to the door. Decals! It's sticker time. So when you're putting on stickers on something like this, check your references, check them again, and check multiple sources. Obviously I'm going to use screen caps from the movie, and I'll put some up on screen. But also check with other builders if this has been done before. I look at RPF, I look at the Ghostbuster groups on Facebook to see what people have done, kind of how they adapt for certain situations. This is being oversized, I kind of got to adjust and split the difference, so to speak, to make sure that these look natural and like they fit. I'm really excited about this. I'll just play some music and you guys just watch me stick them on. So that does it for the labels on the Ecto Containment Unit. And if you want to pick these up, I actually got a whole set from Fanstar with 2 ends on Etsy. And a guy named Justin, he's doing them. He meticulously went through these and I talked to him a little bit. It's a nice vinyl material. And it's actually the exterior and interior. So I'm just using the exteriors for the outside of the unit, but he also includes in the kit the internals for the trap bay. So if you like these, feel free to reach out to him. They're a great set. So this is my Ghostbusters Ecto Containment Unit electrical panel cover. Hope you guys liked it. Please like and subscribe if you do. Share it. The more people that see it, the more people that would build stuff like this. It's not hard. You just have to apply yourself and think it through. As long as you have a plan, anything's possible. This is another Fischer Builds. See you guys next time. This is so much harder with you like judging. Is that what you're gonna say? Is that what you're
I love
go?
everything you do. Stop.
Is that what you're gonna go with? Now you just place your Ecto Containment Unit wherever you need it. Just on the wall. Is this where you want it? Okay. Why do I still have a screw?
There's always an extra one.
Did I do 2 on this side? I don't think I did. Yeah, I did. Son of a